All right, we're going to take a look here at how to solve one of these triangle similarity problems when we've drawn an altitude through a right triangle, and by doing so have created a total of 3 similar right triangles. So the first thing that I'm going to do is label the original triangle, the large triangle A, B, C. And the next thing I'm going to do is highlight that triangle in red. And from here on out, I'm going to refer to this as the red triangle. All right, from here, what I'm going to do is create what I refer to as a breakout figure. That's just a kind of a little shorthand phrase. What I'm referring to here is that I want you to take the triangle and I want you to draw a little model of it off to the side, separate from the original figure. And go ahead and relabel everything you know about that triangle. So once again, I'm going to make a copy of ABC. My right angle is down here in the bottom left-hand corner. And I only know one thing about this right triangle, and that is that the hypotenuse here is going to be this entire length AC. So that's going to be 2m plus another m. That makes 3m minus 4. So I'm going to label that on the hypotenuse of my little breakout figure here. 3m minus 4. Perfect. Okay, next thing that I'm going to do is draw attention to this altitude that was drawn from the right angle of the original red triangle ABC out to the hypotenuse AC. When I do this, I actually create a small similar right triangle, and I'm going to refer to this as the blue triangle. And just like with the red triangle, I'm going to take this little blue triangle and I'm going to break it out to its own separate little figure off to the side. I'll make another small right triangle. I'm going to label that right angle in the bottom left-hand corner, and I want to orient this triangle similar to the red triangle so that I can compare corresponding sides. We don't have a label for the right angle here, so I'm going to go ahead and add label D. And so this blue triangle is going to be at the right angle, vertex D, across from it A, and above it, vertex B. So I've got triangle BDA, which is similar to ABC. And I'm going to go ahead and label the things that I know about this triangle. I know that the base, AD, is m minus 4, and I know that the height, DB, is 8. So now I've got 2 out of the 3 similar triangles. I'm going to return back to that altitude real quick, and I'm going to take note of the third triangle that is formed, and that is what I'm going to refer to as the green triangle, and that is this guy right here, which is triangle CDB. Once again, I'm going to make a third and final little breakout figure off to the side for the green triangle. I'm going to orient it in space exactly the same as the red and the blue triangles so that I can compare those corresponding sides. So again, I've got the right angle in the bottom left-hand corner, and I'm going to take care to label my vertices correctly. At the top, I've got vertex C. Down at the right angle is vertex D, and across from it to the right is vertex B. Now I'm going to label the information that I know about the green triangle, and that is going to be, it looks like the height, CD, is 2m, the base, DB, is 8. Now let's check out a few things here. The red triangle, I only know the hypotenuse. With the blue triangle, I know both the base and the height, and I see that those are analogous to the base and the height of the green triangle. Overall, in this question, I'm asked to find the value of m. So my job becomes figuring out which of these 2 triangles can be compared to one another to find the value that I'm interested in. Now, right away, I can see that I'm most likely going to have to discount the red triangle, and here's why. Even though I have a side that has an m in it, I don't have anything else to compare it to. So I don't have another hypotenuse to compare the hypotenuse of the red triangle to. So that one's probably going to be a minor player in this particular problem. For that reason, I'm going to move it off to the side for a little bit. And I'm going to bring blue and green side by side so that we can see what comparisons can be made. Well, it's very easy to set up a proportion here. Notice I've got the height compared to the height, and I've also got a base that I can compare to the base. So let's go ahead and set up that proportion and let's see what we can do. I'm going to compare here 2m to 8, and then I'm going to compare 8 to m minus 4. Now let's make a quick note about how we set up this proportion. Up here on the top, I'm considering the dimensions of the green triangle, and down here at the bottom, I'm considering the dimensions of the blue triangle. All right, from here, I can solve for m. That's the only variable that I have in this equation. I'm going to use cross multiplication as a strategy for simplifying the equation, and then we'll solve from there. All right, let's recap what we have so far. I've got 2m times m minus 4 over here on the left-hand side. Over on the right-hand side, I've got 8 times 8, which gives us 8 squared. Distributing this out, I've got 2m squared minus 8m equals 64. I brought all terms over to the left-hand side of the equation, and I notice that I have a common factor of 2 in every term in the equation. Divide everything by 2, and this simplifies things a little bit for us. I've got m squared minus 4m minus 32 equals 0. I'm going to use a factoring approach to solve this quadratic. I need two numbers that multiply to give negative 32 and add to give negative 4. That'll work out as negative 8 times positive 4. That gives us the negative 32. And the sum of negative 8 and positive 4 gives the negative 4. Now remember, when you're finding the value of m from this factored form, we're looking for the value of m that makes this equation true. In other words, I need m equals positive 8 and m equals negative 4. We are not interested in the negative solution this time, and that's because we are talking about a geometric figure. If I were to use the negative 4 up here as my m, I would have negative 4 minus 4. That gives a negative 8, and negative 8 cannot be the base of a geometric figure. So we're going to go with the positive solution here. That'll be m equals 8. 8 minus 4 would give us 4. So the base of the blue triangle is 4, and m itself is going to be 8.